Hello, today we're going to be learning about Pythagorean theorem. We're going to use the Pythagorean theorem in triangles to find side lengths, and we're going to use the converse of Pythagorean theorem to decide if a triangle is acute, obtuse, or right. Now, first we need to know what the hypotenuse is. The hypotenuse is the side that's opposite of the right angle, and the legs are the other two sides. So in a right triangle, when I have my right angle, this is my hypotenuse, and this is a leg, and this is a leg. Now, in a right triangle, if I make a square connected to each side, and you count up, this would be a side length of 3 and a side length of 4. And if you count up all these squares, you would add to 9. If you added up all these squares, you'd get to 16. And you add all these squares, you'd get to 25. And that works with any right triangle. Not these particular numbers, of course, but if you look at 16 plus 9, that's going to equal 25. And that's what Pythagorean theorem says. A squared plus b squared is equal to c squared. Now, hopefully you've learned about Pythagorean theorem before. We've used it through the first half of this year. So now we're going to do it with using the rules that we learned with square roots. Now, the first couple are just using the normal rules. 8 squared plus 15 squared is equal to c squared. This becomes 64 plus 15 squared is 225. And then when I add these together, I get 289. And when I take the square root, I get 17. That's nice when it works out perfectly. 8, 15, 17. Now here, if we want to use Pythagorean theorem, now c is the hypotenuse. So the first step is to do 5 squared plus b squared equals 13 squared. And then you square them, subtract them from both sides to get 144, square root them, and this side is 12 centimeters. Now there's Pythagorean triples. These are the ones you just saw, 7, 24, 25, 3, 4, 5. These are right triangles that match perfectly. That means there are no decimals in these sides. Also the multiples of each of these. So if I took each of these and multiplied it by 3, I would find a right triangle where the 3 sides were all whole numbers. Now there's another problem, Pythagorean theorem in 3 dimensions. So if I want to find the longest stick that can fit inside of a box like this, that would be going from one corner all the way to the other corner, or from up here down here. Now, there's no right triangle right from that. But what we can do is a box has right angles on each side. So we can draw this B across here. And when we have that, we have a right triangle on the bottom. So we can use a squared plus b squared. 81 plus 121 is equal to 202. Square root that, and you have 14.21. Now that you have 14.21, and you know this height is 8, we can use a squared plus b squared equals c squared again to find this diagonal of the box. When you square those, you get 64 plus 202 is 266. Square root that, and so this hypotenuse is 16.31. Now a shortcut for this is the Pythagorean theorem in 3 dimensions. So instead of a squared plus b squared equals c squared, a squared plus b squared plus c squared equals our distance squared. So you do that just like Pythagorean theorem, but now you put all 3 of these dimensions in, add them up, and you get 266, which is 16.31, which is what we were looking for. All right, now the converse of the Pythagorean theorem helps us tell whether a triangle is obtuse or acute. And we can look at the relationship between these sides. So how if I have 49 and 64 and 169, if I add these, are they greater than or less than this number? Or over here, if I square these, are these numbers, if we add them together, bigger or smaller than 36? Over here, the two smaller sides are less than the big side. Over here, the two smaller sides are greater than the big side. So, uh, this goes through finding it. So if a squared plus b squared is greater than c squared, then the triangle is acute. If it's less than c squared, then that triangle is obtuse. And if it equals, then we know the triangle is right. So if I have these three and I want to classify them as right, acute, or obtuse, first you check if a squared plus b squared equals c squared. So you take the two smaller values to be a and b, and you just check to see if they're equal. If they're equal, which this one is not, the c squared is too big. Since that's too big, we know that this has to be an obtuse triangle. Let's try another one. 7, 40, 41. If we plug them in, the two smaller ones are a and b. Check them out. This one is smaller than our hypotenuse, or our right side, and so that means it is, again, obtuse. Now if there's square roots, this gets a little tricky. It's actually a little bit easier, because if you square a square root, it just comes out to that number, 10 and 13. And 4 doesn't have a square root, so we square it. Now I have 23 is bigger than 16, so that has to be acute. All right, now you can do the success criteria and see if you can finish up the homework.